Hello everyone. Thank you for joining DataCon LA 2022. Welcome to Emerging Tech. My name is Veeti, your host, and your co-hosts today are Neal and Satnam. Please be mindful of our COVID regulations and keep your mask on if you can. Also, silence your phones during the session. Don't hesitate to raise your hand if you have any questions. This session is currently being recorded via Zoom and the recording will be available in a few weeks. Today, we have our guest, Neal Fultz, and he will be talking about PackMap ensembles for occupational specialization in the California cloud workforce. Neal is principal consultant at njnm Consulting and here to discuss about the PackMap ensembles. He is a computational statistician, data scientist, and open source enthusiast with years of experience with over 30 Python, R, and JavaScript packages to his credit, as well as 2022 Google Summer of Code Mentor. Now, without further ado, I'll hand this over to the speaker. Thanks for being here. Thank you.
Great, thank you. Got a couple more people coming. Give them a second. Let me just warm up a little bit. Quick show of hands. How many of you all are in academia, in industry, consultants? Okay, cool. All right, well, I think there'll be a little bit of something for everyone here. So I'll just kind of get going. So I always bookend my talks with an executive summary. So if you're an executive, this is all you need to know, I guess. So what is this project? So the LA Community College system. So there's about, call it 10 of these different schools around here that do feed into the CSU system. USC, obviously, the UCs. So the community college system, they needed a way to identify curricula gaps in their cloud computing program that they've been launching. And I was brought in as a data consultant, and by applying BERT and PackMap and some elbow grease, we can find those gaps to help them fill them in. So that's what we'll be talking about. So a little bit of background. So what is the California Cloud Workforce Consortia? It's a large grant run by the LACC system to develop cloud computing skills in the LA workforce. There's over 2,000 annual job openings in LA County alone that need these skills. So we want to, build that skill set for the people here. And these are industry standard skills to understand and develop applications for the cloud. So that means, AWS, GCP, the Microsoft one, etc. But the big problem there is that cloud classes, as they're taught in a classroom by a professor, that's going to lag behind what cloud jobs need now. So how do we figure out what to teach in those classrooms so that people get the jobs of the future? And more generally, how do we figure out if and where there is that mismatch between what the industry needs are and what's taught in classrooms? How can we even think about that, right? So first thing what we're going to do is we're going to get data on the curriculum that they're teaching right now. Santa Monica College, luckily, has an online system tracking all of this. Other schools in the area use good old hard copies and filing cabinets. And this is a course outline of record. This is used during the accreditation process. And this lists everything you need to know about the class. So a tentative schedule, how many assignments are in there, what the textbook is. Importantly, there's these objectives and student learning outcomes that we're going to zoom in on. And then there's programs which are sets of classes. So these could be minors, majors, certificates. Certificates are very big for cloud computing because typically people already have a degree in computer science generically, and then they want to get a cloud certificate. So what do those look like? So course objectives look something like this. And they're usually upon completion of the course, the student will be able to, describe the AWS well-architected framework. And what are student learning outcomes? They look a little bit different, but similar kind of overlap, different language though. And so just to call one out, so here's one: describe design principles and apply the best practices of security in AWS. So keep a couple of those buzzwords in mind. We'll we'll be circling back to this. So what about the data that we can get for actual jobs? So there's a fantastic database out there put out by the federal government, by the Department of Labor, called ONET. It's free to use. It's under a Creative Commons 4.0 license, so anyone can use it as long as you cite them back to them, like I'm doing now. And this is a very, very detailed taxonomy of the different jobs that the federal government hires or people in industry use. So we've got an example of what this looks like on the right. So we've got information security engineers. It's got all the different tasks that might be part of the job, different work activities. There's some great data on wages and if this is a growth sector or not. So let's zoom in on one of these tasks. So develop information security standards and best practices. We've heard some of those words before, right? How do we know if that matches up with our information security course though? Because it's not quite exact. So here's the idea. There's like a mathematical space, we'll call it a skill space. So maybe we've got soft skills on one side and technical skills on the other. So it's kind of just abstract, but we can imagine, here's our information security engineer job. Those tasks kind of need different types of skills or whatever. And then the courses we're teaching can coexist in that space. So we've got our yellow job dots and our orange class dots. So this is all just kind of me drawing little pictures in PowerPoint. It's not real yet, but if we could get to something like this, we could try and interpret it, right? So if the dots are close together, maybe that tells us something. Maybe they're close enough that we call them a match and that this course matches with that job. And it tells us something if their dots are far apart, right? There's misses in this set, or there's areas where there's no overlap. That's the gaps that we're looking for in this case. So how are we actually going to implement this? So this is a pretty standard playbook. We'll take some stock neural network that, we'll get from Hugging Face or whatever and fine tune it, right? Apply some dimensionality reduction, very aggressively do hyperparameter tuning, and then score and aggregate. Can turn this around in a couple months and everyone's happy. That's the dream. So there's a little bit of a hard mode here. So because the client has free DevOps in the form of all these students getting their cloud computing certificates, the LACC and Santa Monica College specifically wanted to punt on all the downstream applications and have them be class projects, right? So as a consultant, therefore, I can't use anything that those students wouldn't be reasonably able to pick up in 6 weeks or whatever. So this cuts down on how fancy we can get with our solutions. I'll be circling back to that too. So part one, implementation. So we know students are going to have to use this, so we can't go too crazy, but what we can use is this thing called DistilBERT, which is BERT, but smaller, faster, cheaper, and lighter. And they say it's 40% smaller and 97% is good, which is great. Most importantly, a student could run this thing on a workstation, runs fine on Colab in that environment also. But there's one thing I would call out. So when they say it's 40% smaller, the output space is still 768 dimensional, which is going to be, if you were trying to do an analysis on this, that might be challenging, very difficult to interpret. So then what we're going to do is stack this into some dimensionality reduction algorithm. In this last year, I've kind of switched over from UMAP to PACMAP, which is the PACMAP in the title of the talk, which is an acronym for Pairwise Controlled Manifold Approximation Projection. The trick here is that it's using a multi-stage optimization that includes both far neighbors as well as the nearest neighbors. The review paper that is out there is extremely good, so I will kind of defer to them on kind of the technical details, but I will take kind of the picture that's really compelling from their paper. So when they compared their algorithm versus kind of the previous work, it's much, much more stable than UMAP is with respect to the number of neighbors it's using in its approximation or TriMAP. And so this is great because that means that you're not getting completely different answers every time you run it. And it's also very fast. So that's a nice thing to use too. So great piece of software. I will say though that it is kind of bleeding edge. So in the 6 months I was working on this project, there was multiple breaking changes in the package. You know, they were using some kind of non-standard interfaces that made more sense to like, you know, graduate students than it would to a practitioner in industry. They had very interesting defaults chosen for some of the tuning parameters. But you know, they were very, very responsive in working with me. They would like answer tickets on GitHub in like 2 hours or something, which doesn't even make sense because they're like in Duke, that's 3 hours ahead. And I will say this, based on like my spot checking and kind of exploratory work with this is very good at consolidating redundant information with this type of data. So if you're doing NLP, like PacMap is a great thing for it. It's like the cheese to go with the wine. That's how I kind of think about it. But this didn't work so great. And the reason is it's only as good as the input. So I'd mentioned this before that like course objectives and student learning outcomes, we're saying the same thing quite often, but using very different language. And same thing is going on with the tasks in the ONET data. So if you apply dimensionality reduction to it, it's going to make the clusters just, oh, we're going to put all the course objectives in one corner and all the tasks on the other. This isn't helpful. So how do we work around that? So a couple things we can do. We can go even wider and not just rely on DistilBERT, and we can leverage some domain knowledge. So if you talk to the professors about why are you using those weird words in your learning objectives, they got like a reference, they can cite their sources. So we're gonna take those two strategies. So the first one is this Bloom's taxonomy, which I'd never heard of, but like whenever they're writing those like course objectives, there's like some educational framework for doing so. And they kind of break it out in this different levels of a pyramid. I thought this was kind of interesting, so I thought I'd share. And more interesting than that is when we look at the coverage on the tasks in the ONET database, 50% of tasks fall straight into this taxonomy, which is just based on like keywords that like someone came up with in the 90s. So that's really interesting, right? Also, I'll call out that creating, which is the top of the pyramid, appears in the most tasks. So it's almost like they got the pyramid upside down, or I don't know. It says something interesting about like what tasks are actually getting used in jobs. So we can plug that in, right? And so this leads to what I call a PacMap ensemble, I guess. We're gonna take the DistilBERT embedding, we're gonna take bag of words in a topic model, so good old NLP. And then we'll take the Bloom's taxonomy, which is implemented in like a 60-line regex. We'll plug all of them straight into PacMap, and then that reduction I'm calling an ensemble embedding because it's 3 different models that have been distilled into like a single fit. So that's great. It seems to at least fix this thing where all the objectives go into one corner of the space. But I did break my promise to not do anything that students couldn't handle, right? So that's not good because we're using 3 different models and 3 different frameworks. Okay, so just to take a quick look at what these embeddings look like. This is color coded by the different top level job codes. And so what we can see is that, at least on these 2 dimensions, lots of different types of jobs have lots of different types of tasks, but it's all kind of, filling the space. We got this green dot at the very top. Anyone want to guess what that is? That's actually college professors. So in the ONET database, all the professors have these job tasks of like, must teach biology, must teach computer science, must teach organic chemistry, et cetera, et cetera. So it puts all of those like way up at the top. So I thought that was kind of funny. But like with your regular jobs, like they're mostly in that big, I don't know, shoe-looking cluster. And there's different corners of it that correspond to different tasks. So that's great. So then we can get to our like tuning stage. We need to tune all of these things. So this is a massive pain because we've got multiple submodels that need to get tuned. And this really hinges on choosing a good loss or metric. All the defaults out there are not k-fold cross-validated. So that's an easy thing to add in. And then the second thing to add in is also we can go non-parametric. So we can use like a Spearman stress, because stress is kind of like, you can think of it as a correlation between like your full distances and your low rank approximation. So go Spearman and it'll like match up with what PacMap is trying to do. Another thing that I thought was interesting in the, 15 years since I first learned about PCA, there's always this question of how many components should you use? So I was taught, in graduate school, oh, we'll make a scree plot and we'll like pick the elbow, or sometimes they'll just say, oh, we'll just choose enough to cover 95%, or they'll say, use your intuition. So anyway, there's been some theory developed around this in the intervening years. Gavish and Donahoe, they have like a formula that you plug your data into, and it gives you like the optimal number that's going to capture it. Other comment there, so that is under linearity. So that's great if you're doing PCA or, the singular value decomposition, whatever. PacMap is a nonlinear transformation, so it can kind of fold the space around. So we can treat that as an upper bound. So 270 is our upper bound. That's already bringing it down from the 768 dimensions of the BERT, plus the 3,000 of the bag awards, plus the 5 levels of Bloom's taxonomy, right? So get that down to 270. We'll aggressively shrink this. Okay, so do all that, and now we actually got these, points in space. And again, I kind of alluded to this before, like this is still pretty abstract. Like what we need to do is like take these dots and like get this down to like some formal metric of what closeness is, right? So if we make one of these plots for a specific course and a job pair, looks like this. And so you can see like the green ones, they're still a little bit to the left, but there are some of them that are kind of actually touching the red and blue ones, which are coming from the syllabus. And in other dimensions, it looks completely different. So this is just 2 dimensions I picked. So how do we do that? So what we're going to do is we're going to take our orange dots and our yellow dots, and we're going to, for each combination of those, come up with a metric. So then the question is, okay, what do we fill in with the cells? So there's other consultants over in DC, they were using cosine similarity. That's going to have problems with our setup because we're using PacMap, which can move things around. Cosines are from triangles. Triangles have 3 points. There's that corner at the origin. Ours doesn't mean anything, so we can't do that. Using distances, or maybe a Mahalanobis distance, something like that would probably be okay. Those are very difficult to interpret because these are distances on some imaginary space we've constructed. So instead what we can do is we can take the cumulative distribution of all distances with respect to each task and use that. And you know what? Educators love that because you get a grade, 0 to 100. But then we've got this table full of grades, and how do you aggregate it? So if you imagine a job, reading a job posting, for example, you would expect all the tasks to be quite different. And so that's going to induce sparsity, or some of your course objectives will be close to some tasks and far from others, right? And we don't want to penalize that. So instead of just taking a straight average, like the DC consultants do, we're going to do like a mean of a max kind of thing. We'll get 2 scores out of here. So we'll get one that's kind of like the relevance of the task for the course, and other one is kind of the other way around. And we can forcibly symmetrize these if we have to. So what does this actually look like? We get one of these things for every single combination of jobs and tasks. For this one, I would call out that blue is good and gray is bad. That's all you really need to know to interpret these things. And here we can like quite clearly see the gaps in what they're teaching and what they're not. And so I'll call out my favorite one. Design and conduct hardware or software tests. And I did computer science as an undergrad, and that was definitely something I had to learn on the job. And so I think that's kind of interesting that it showed up pretty directly like that. And we can also, for a given course, assess the relevancy of each of its objectives to different different types of jobs, right? So imagine we have a video game course. How much more relevant is it to a video game programmer than a regular one? Well, now I can answer that question. It's 7 points more relevant to the video game programmer. So this kind of thing was also very useful for the client. Okay, so now I want to go back to this kind of like setup. Like this is too complicated, like I mentioned, for students, right? Because we've got DistilBERT and PyTorch, we've got the bag of words stuff with NLTK, we've got Bloom's taxonomy, which is hand-rolled, stacking them into PackMap. So what we're going to do instead is another round of fine-tuning and then completely skip all the other stuff. And now you're just left with a regular Hugging Face transformer that you can just deploy as an API and call it good. You know, all the other stuff is still in there, but it's no longer needed for the students to worry about. So just to wrap this back around, so the community college system here in LA needed a way to identify the curricula gaps in the cloud computing program. You know, if we use our different components that are available, so BERT, PackMap, and some clever aggregation of the scores that come out of it, we can find the gaps. It's not trivial, but we can do it. Okay, and so then we got some time for Q&A. Thank you all for attending, by the way. Yeah.
Yeah, do you have any consideration as to whether the jobs that you're evaluating are entry level versus more senior types of jobs that expect someone to have some experience?
Yeah, so that didn't make it into the model I'm using, but it is in the ONET data set and it manifests in 2 ways. So in ONET, they have these hierarchy of job codes. And so within 2 levels of it, they'll have a entry level versus senior level version of the role. The other thing that happens is the more senior you get, you just get more and more tasks tacked on to your job description. And so as that happens, it would force that set of requirements to grow. And so that should decrease your final score or whatever. Good question. Thank you. Other questions? All right, I write my own questions while people think of better questions. Any shout outs? So I'd like to give a special thanks to Solomon at Scopeway, Nancy at Santa Monica College for running this contract. Also Ankush, Jeremy, and Rebecca at Handshake. We used a similar approach with UMAP on chatbot data back in the day. So this is kind of like an evolution of that. And also huge thanks to the PackMap team at Duke for, again, being very, very responsive to any technical questions I had. Other questions? No? All right, who am I? Oh, yes.
Sorry, one more. So in terms of I really liked kind of having the visualization of ones with match really well, very much thing. I guess I would assume that some skills on that job description should have been dealt with either in a different course or at a different point in that academic career. Let's say we're talking about computing, then there might well be something that is communicated well with statements, but should that be the primary objective of a cloud computing course? I would argue probably not. That's something that should have been dealt with at some other point in the academic career. Was there a way that was accounted for?
Yeah, and so I had mentioned before that you need to be careful when you're constructing your final score and to not just take an average, right? Right. And so if you're,
so that was the max that part of it.
Right. So what you can do is you can basically stack multiple courses together, just column bind them or whatever, and then apply the exact same scoring function, and that will adjust for different. Again, if you're developing a certificate or a minor or something like that, you want to make sure that the minor as a whole covers all the bases, even if individual classes might have a gap here or there. And I will say that for testing, for example, that's something that I feel could be brought up in multiple classes. But you're right, other things being able to communicate effectively or something like that. Yeah, great question. Yeah. So other backup question, who am I? my name is Neal Fultz. That's my email. You can email me if you have any other thoughts. I mostly do data science and ML consulting. I'm a recovery and software engineer. Primarily, I work in ad tech and fintech, but other things come up as well. So like this contract came up, so I took a stab at it. How did I find out about this project? So I was presenting at a different conference, Ideas, in 2017, which was in downtown LA, on a project I did with DataKind for the University of Wisconsin Parkside. And another attendee remembered me 4 years later and reached out. So, you know, that's some value from doing these kinds of talks, I guess. What about the program level? So yeah, so you have to be very, very careful about between course sparsity when you can concatenate the matrices. And future work. So I think this is the last one, yes. So skill space is generic. So you can imagine doing a lot of other different things with these like points in space kind of setup, right? So one thing that they're very interested in is using to determine if courses can transfer or substitute between different universities. Right now, that's like, you know, they email a syllabus to a person in the admin staff, and then they like read both of them and make a decision. So that's one thing. Another thing you could imagine using this is like a resume generator or a job recommender based on student transcripts. So if you're 2 years into your degree and you're taking these things, which are the most relevant jobs, or make me a resume that's well suited for those jobs you specify, things like that. The other thing that I'd like to spend some time on is identify the missing Bloom level. So I mentioned there's like this 50% coverage in the Bloom taxonomy of the tasks. Well, what's in the other 50%? I think that's like a really interesting question, probably for like a professor in education or something like that. But it's like in the data somewhere. So, all right. Any other takers? All right. Thank you all very much.